Hey guys, and welcome back to another GCSE Maths Grade 9 exam question. So here today, we're dealing with a geometrical proof sort of question. We're given these two circles, and we're given these two lines between the circles. And we have to prove that the quadrilateral here, A, B, C, D, is actually a rectangle. So this is quite a tricky question, and it was 4 marks off the top of my head for this question, and it's from quite an old paper, quite a few years ago, but it is quite tough. So let's begin with this, and where can we start with? Well, we're told here that DB and AC are tangents to both circles. This is very important, and the reason why this is important is because we know now that if these are actually tangents, what that means is that D, so from D here to E, that means that that length there must be the same as from A here to E. And that's because tangents from an external point are equal in length. So from D to E, it's the same length as A to E. And then similarly, from A to E, it's the same length as E to B. So from here now, E to B, that's also the same length. So these three are the same length. Now, what else can we gather from this information that we're given? So we're told E is the midpoint of A to C. So what that means is that AE is going to be equal to EC. So let's write down some of this information that we've got so far. So what have we got so far? Well, we know DE is equal to AE. That's what we established just a second ago here with the tangents being from an external point. And we also know that AE is equal to EB. Because they're tangents from a point again, and we already established that AE is equal to EC, because C is the midpoint, so they must be the same length. So EC here. This is given to us though with this fact, so this is given. So that's given. So what can we do now? So let's piece this together, what we know. So we know AE is equal to DE, so AE is equal to DE. DE. We know DE is going to be equal to EB, right? Because if AE is equal to DE, that means if AE is equal to EB, that means DE is equal to EB. So DE is equal to EB, which similarly means that EB is equal to EC. So therefore, what we now know is that the length DB must be equal to AC if all these are equal. So this implies that DB is equal to AC. So why is this important? Why is it important that DB is equal to AC? Well, let's go back to black again. So imagine I was to draw this rectangle that is claiming. So from A to B, B to C, C to D, and A to D. So that's my rectangle right now. I know it's a bit scruffy there, but that's what it's going to look like. Now, what we're saying is that A to C is the same length as D to B. Now, this is important because if this is actually a rectangle, the diagonals have to be equal, which we've just said. DB is equal to AC, perfect. And they have to bisect each other, which they clearly do. They both pass through E. So, we have actually now proven that this is a rectangle by proving all these lengths are equal here, or the respective lengths are equal, and by proving that the diagonals are equal in length. DB is equal to AC, so therefore the diagonals are equal, and they pass through the same point here. So therefore this proves that it's a rectangle. Therefore ABCD is a rectangle. So that's the trickiest part to this proof, the establishing the basis here of the tangents. You know, from an external point, you can know that DE must be equal to AE, and if that's true for this side, AE must also be equal to EB. You know, we also know that AE is equal to EC, because this is the midpoint, E here, and then we can sort of join these points up together here, using this fact here. This shows that the diagonals are equal, and therefore it must be a rectangle. So that's quite a tricky proof, guys, and you've got to be very careful in how you articulate it, but I hope that's okay. It is quite a tricky proof. If you're unclear of anything, be sure to leave a comment below.